have a lot of advantages at VDL, but I think also a lot of other other builders of vehicles or ships can have a very big positive impact of the standard. And for example, we are making now trucks for plastic omnium and Colruyt, and we are making trucks for Toyota, and both can use the same fuel cell from the different supplier. And the redevelopment of those two trucks shortened by more than a year or half year. And this is a very big opportunity for us, and also with the same standard fuel cells we can make generator sets, everything, and it is like a Lego block, and with a Lego block you can do everything, and we can do everything with this standard. We have two kinds of industry players. The one is who are making the fuel cell, and the other one is who are using the fuel cell. On using the fuel cell, you see now also that the Clean Hydrogen Europe in the next goals, you see a lot that it is mandatory to use the StasHH standard. And so a lot of people are doing this, and this standard is not for a product which is made 20,000 times a year, but is made for the smaller companies or the smaller number of products, let's say 50 or 100 per year. Then you are not making yourself a total new fuel cell system. On the other hand, you have also the fuel cell suppliers. Advantages of doing this: they can have let's say a higher production, and everything is the same, and only the fuel cell user has to integrate it. And you see now also that also parties which were not part of StasHH are using the standard, and we are very happy about that, of course. Those parties is at this moment one of the most important one is Cellcentric, which is making the fuel cell for Mercedes and Volvo, or for Daimler and Volvo. Now the adoption of the standard will go very quickly, but then also the hydrogen economy has to be, let's say, increased. And then you see that a lot of people who have heavy duty equipment, that for them is the most easy way to integrate the fuel cell in their system. On the other hand, Clean Hydrogen Europe is also stimulating the use of the standard. We started quite a time ago with a European project, H2O, together with Colruyt, and we should make also again 2 fuel cell trucks. And in that time we didn't want to work again with a new fuel cell builders, and so we had a partner, L. from another European project, and we discussed to make the first standard of that fuel cell. But that was before StasHH. So this standard we developed at the H2O project was used as basis for the standard of StasHH at the end. And the nice thing is that the standard was adapted, also a little bit like the first one. And so Toyota, which is in the next 5 vehicles, adapted their fuel cell to that standard, and now we could very quickly redevelop the vehicle from the plastic omnium, or in that time L. fuel cell, to Toyota. And that was for us very quickly. And in the standard there are 3 ways. One is mechanically, how big is it? The other one is electrically. But the first one is the most difficult one, that's the communication digital. And normally to get the communication right with the fuel cell, it takes you maybe 1.5 years or a year to develop. And now the fuel cells all speak the same language. This can be done in 1 or 2 weeks. And there are very big gains in development time for fuel cell vehicles. The nice thing of the StasHH project, it's like a Lego block, so you can retrofit it anywhere. Depends on what product. Is it a truck, is it a ship, is it an off-road machine or something like that. You have a block and you can put it where you want. In our case, we had a low cabin truck, and we put the fuel cells not where the engine is, but where the diesel tanks are on the side of the vehicle. But our competitors, they use, for example, the engine bay where they put the fuel cell. But for buses, for example, you can put it on the roof, and so you have a block, and it is like an AA battery. They are not always on the same place in the same product. You can put it everywhere. And also the nice thing of this module is that it is a module which can be multiplicated. So if you have, for example, one module of 100 kilowatt and you need 1 megawatt, you can put them next to each other, and then you have 1 megawatt. The first trucks we made, where we already used a little bit of the standard, was H2O. That was even before the StasHH standard. And the trucks we are building now are also not from an other project, but they are built for Toyota to show that their fuel cell and trucks can be used for their logistics between their factories in, let's say, France, Belgium and Germany. And we have also another project with a genset. This genset will be used is in StasHH tested, but will be used also in another Interact project for making heat and electricity for a building. VDL is also looking further than mobility. We are looking also on stationary use and also on shipping with fuel cells. For that reason, a genset can be used on a ship or for stationary applications. One of the applications we think of is that we store hydrogen, for example, in the summer and use it in the winter. And then we need a genset which makes electricity for the building and also heat. And those integration, we did an integration with a Freudenberg fuel cell, also StasHH approved in a container, and this was done the last 5 months and already tested also recently, and this will be used maybe on other future projects also together with other partners. The nice thing of a Lego block, you can use it for everything. So everything where you have something to do with hydrogen, gensets, shipping, trucks, off-road equipment, trains. And so the nice thing of a standard block is that it is multiple uses. We are looking for an ISO standard together with the CEA in France. This is quite a big process to do. The first step was positive, then some countries had to approve it, but this whole process can even take more than 5 years. Let's say the basics of the whole StasHH were 2 parts. First, to make a standard on paper, but the second one, which was very important, that also according to standard fuel cells were built by the suppliers. If this part was not part of this project, then it would be only paper. Now we have already from 7 suppliers, we have a lot of different fuel cells, and that's nice. And the other part was that we tried to get it in a world or European standard that we can use to the future.